Welcome back. Let's learn how to simplify variable expressions using the properties of multiplication. Alright, so in the previous lesson, we looked at the properties of addition and how they can be used to help us simplify variable expressions. But now in this lesson, we are going to look at the properties of multiplication. We'll start by going over the properties using real numbers or using constant values, and then we'll look at how to apply them to variable terms to help us simplify variable expressions. Okay, and so in total, there are 5 multiplication properties. There's the commutative property, the associative property, the zero property, the identity property, or sometimes it's called the one property, or the property of one, and then finally there is the inverse property. And so let's get started and take a closer look at the first property. And first up we have the commutative property of multiplication, which says that if you have two numbers represented by a and b, that a times b is equal to b times a. And by the way, if you haven't seen this notation before, when you see a little dot in between two numbers, that refers to the multiplication of those two numbers. The reason we use that instead of the typical times symbol that you're used to seeing is because we don't want to confuse that times symbol with our commonly used variable of x. Okay, so we try to not use that times symbol anymore in algebra to avoid any confusion. We'll either use a set of parentheses or this little dot to indicate multiplication. Alright, but anyway, the commutative property says that if you multiply two numbers together, it doesn't matter what order you multiply them in. You can take a times b or b times a, you will get the same answer. The order of multiplication does not matter. Alright, so for example, if a is equal to 2 and b is equal to 3, and we were to test out the commutative property, we would have 2 times 3, and we're saying that that would be equal to the reverse, 3 times 2. Alright, and we know that 2 times 3 is equal to 6, so we have 6 is equal to 3 times 2, which we also know is equal to 6. Alright, so clearly the commutative property holds true for those two numbers. And it will hold true for all numbers, including negative numbers. If you take a look at this example, if a is equal to negative 4 and b equals 2, we could test the commutative property again, and we'd have negative 4 multiplied by 2, and that would be equal to 2 multiplied by negative 4. Alright, and by the way, when you multiply by a negative number, sometimes it's more convenient to represent that by putting parentheses around the negative number, so that would still represent 2 times negative 4. That's what I was referring to earlier by using a set of parentheses to represent multiplication. Okay, but anyway, we're saying that negative 4 times 2 should be the same as 2 times negative 4. And that will be true here because negative 4 times 2 is negative 8, and then 2 times negative 4 is also negative 8. Alright, so it doesn't matter the order in which you multiply two numbers together, even if one is negative, one is positive, or if both are negative, the order of multiplication does not matter. Alright, so that's the commutative property. Let's move on to the next one. Here we have the associative property of multiplication, which says that for three numbers, a, b, and c, if you multiply a and b, and then multiply them by c, that is the same as multiplying a by the result of b times c. Alright, in other words, the associative property further proves or further shows that the order of multiplication does not matter. It doesn't matter the order in which you multiply three numbers together or how you group their multiplication, you're going to get the same result. And this does apply to more than three numbers. You could have a string of 4 numbers multiplied together or 5 or 6. It doesn't matter the order in which you multiply those numbers together, you will get the same result either way. Alright, so for example, if a equals 2, b equals 3, and c equals 4, here's what we'd have. For a times b, we would have 2 times 3, and then we'd be multiplying that by c, which is 4. And the associative property says that that would be equal to a, or in this case 2, multiplied by b times c, where b is 3 and c is 4 in this case. So if we do the math here, following the order of operations, you do want to do the multiplication in the parentheses first. So we have 6 times 4 and that will be equal to 2 times the multiplication of 3 and 4. And 3 times 4 is 12. So now, 6 times 4, well, that's equal to 24. So we have 24 is equal to 2 times 12, which is also 24. So the associative property holds true. It doesn't matter the order in which you multiply these numbers together or how you group the multiplication, you will get the same answer. Okay? And this would also be true if you throw some negative numbers into the mix. If a is equal to -4, b is equal to 2, and c is equal to -5, we can show that the associative property still holds true. In this case, we would have -4 multiplied by 2, that's a times b, and then that would be multiplied by c, which in this case is -5, and that would be equal to a, which is -4, multiplied by b times c. So you'd have 2 multiplied by -5. All right, so simplifying here, -4 times 2 is -8, so we have -8 multiplied by -5, and that would be equal to -4 times 2 times -5, which is -10. So we have -10. Now, taking this one step further, -8 times -5, well, first of all, 8 times 5 is 40, but then remember that two negative numbers multiplied together result in a positive value, so the result of that is positive 40. And that should be equal to -4 times -10. Two negative numbers multiplied together make a positive, and 4 times 10 is 40, so we get 40 on both sides of the equation, and the associative property holds true, even when you're working with negative numbers. Okay, so the bottom line here is that the order of multiplication does not matter. If you have a bunch of numbers being multiplied together, you can multiply them in any order that you'd like. You should get the same result no matter what, okay? As long as you actually compute the multiplication correctly. All right, not that you say 2 times 3 is 5 or something like that. Make sure that you do the multiplication right, and this property will hold true. Next up, we have the zero property of multiplication. This is probably everybody's favorite property because it's pretty simple. It says that if you have a number a and you multiply it by 0, it's equal to 0 every single time. It doesn't matter what the value of a is. If you multiply it by 0, you get 0. And of course, using the commutative property that we looked at earlier, this means that 0 multiplied by any number is also 0. Okay, so anytime you multiply anything by 0, the whole thing just becomes 0. Okay, so two quick examples. If a is equal to 2, we could check out this property and have 2 times 0. We know that if we multiply 2 by 0, we will get 0, so the property holds true there. And if a equals -3, it doesn't matter that the number is negative. If you multiply a negative number by 0, you will get 0. Okay, the property holds true. So that's pretty much it for the zero property. Just remember that if you multiply a number by 0, you will get 0. Now for the next property, we have the identity or the one property of multiplication, which says that if you have a number a and you multiply it by 1, you get a back. And then of course applying the commutative property, that means that 1 times any number will be equal to that number a. Okay, so the bottom line here from the identity or one property is that multiplying anything by 1 doesn't change its value. It stays the same. Anything times 1 is itself. Okay, so for two quick examples, if a is equal to 2, you could test the property and see that 2 multiplied by 1 is equal to 2. All right, if you have 2, you multiply it by 1, you still have 2, and so the identity property is true. Same thing for a negative number, such as -3. If a is equal to -3, then -3 times 1 will be equal to -3. It doesn't matter what number you multiply by 1, you will get that number back. All right, the identity or one property is true for all real numbers. Okay, let's take a look at the last property of multiplication. Hey there, real quick, before we get to the next part of this lesson, if you find my tutorial videos here at JK Math to be helpful, then I'd like to invite you to join my membership site, JK Math Plus, where you get access to many perks, including bonus content and my exclusive community. The bonus content includes dark mode versions of my videos, extra example problems, and more, while the community is a private space online where you can post questions, have discussions, and study together with me and other members. To learn how to join and see a full list of everything you get access to as a member, you can head over to jkmathematics.com/plus. I'll have a link for that in the description of this video. So if you are interested in becoming a member, feel free to check that out. It's a great way to support me and the tutorials I make, as well as a great way for you to learn math better. But for now, let's get back to the lesson. Our final property is the inverse property of multiplication, which says that if you have a number a and multiply it by 1 divided by a, that is equal to 1. And then applying the commutative property, the reverse would also be true. If you switch the order, 1 divided by a times a is equal to 1. And of course, this is assuming that a is not equal to 0, because if it was 0, we would have 1 divided by 0, and we don't know what 1 divided by 0 is. That is what we call an undefined value. We can't divide by 0. Okay, so this property holds true, assuming that a is any number but 0. Okay, and what this property is telling us is that a number multiplied by its reciprocal is 1. Or in other words, a number divided by itself will be equal to 1. Okay, and by the word reciprocal, remember back to fractions, that the reciprocal of a fraction is just that fraction, but where you flip the top and bottom, the numerator and denominator. A technically is a divided by 1 because anything divided by 1 is itself. And so the reciprocal of a divided by 1 would be 1 divided by a. A number times its reciprocal is equal to 1. That is what this property is telling us. So for example, if a is equal to 2, we could test out this property and see that 2 multiplied by its reciprocal, which would be 1 divided by 2, or 1/2, will be equal to 1, right? The way that I would look at this is that you have 2 times 1/2, half of 2 is 1. Or you could simply cancel out these 2's because whenever you have a common factor or a value in the numerator and denominator, they cancel out because dividing a number by itself results in 1. All right, you just have that 1 left in the numerator, so 2 times 1/2 is 1. Now for another example, if we have a negative number, such in the case when a equals -3, then -3 multiplied by its reciprocal, which would be 1 divided by -3, or you could think of it as -1/3, that would also be equal to 1, right? Those -3's would cancel out. 1 is in the numerator, 1 is in the denominator. Anything divided by itself is 1, so this just simplifies to 1. The inverse property holds true. Okay, so in both cases, whether the number is positive or negative, the inverse property will be true. A number multiplied by its reciprocal will be 1, or you can just think of it as a number divided by itself is 1. Okay, and so this was the last property of multiplication. And so to summarize, here are the 5 properties of multiplication that we just looked at. The commutative and associative properties highlight the fact that the order of multiplication does not matter. The 0 property highlights that anything times 0 is 0. The identity or 1 property highlights the fact that any number times 1 is itself. And then the inverse property highlights that a number divided by itself, or a number multiplied by its reciprocal, is equal to 1, assuming that that number is not 0. Okay, and so now that you've been introduced to all the properties of multiplication, it's time to take a look at how we can apply them to terms in a variable expression. How can we use the properties of multiplication to help us simplify expressions involving variables? Because all of those multiplication properties that we looked at for real numbers also apply to terms in a variable expression. We are able to multiply different terms and different values together. But unlike with addition, where in order to combine terms or add them together, we had to have like terms or terms with the same variable part, that does not need to be the case for multiplying terms in a variable expression. Like terms is not going to be a requirement for simplifying via multiplication. All right, so regardless of the variable parts, you can multiply 2 terms together. You can multiply 2 constant terms, you can multiply a constant term and a variable term, as well as multiply 2 variable terms together. Now in this video, we're only going to focus on multiplying a constant by a variable term. We will look at multiplying two variable terms together later on in algebra, as there are some extra rules to learn about there. So we'll come back to that in the future. But for right now, we just want to look at multiplying constants with variable terms. So for example, we can multiply 2 by 3x. 2 is a constant term, and 3x is a variable term. Those parentheses around 3x indicate that we are multiplying 2 by that variable term. And when we multiply a constant term by a variable term, what we do is we multiply the constant by the coefficient of the variable term and then just keep the same variable part. All right, so in this case, 2 times 3 is 6, so 2 times 3x is equal to 6x. Okay, that would be the simplification of that variable expression. We started with 2 times 3x, we simplified by multiplying the constant with the coefficient, and we got 6x. Okay, and that process still applies if negative numbers are involved, and if the variable part is more complicated. So if you take a look at this example, we have a constant term of 4 multiplied by a variable term of negative 5xy squared. All right, so in this case, the coefficient, or the number in front of the variable part of the variable term, is negative 5, and the variable part is xy squared. It doesn't matter what that variable part is. To simplify this variable expression, you just want to multiply the constant by the coefficient of that variable term. So in this case, 4 times negative 5 is negative 20. So the simplification here is that this is equal to negative 20 times xy squared. Okay, that is how you perform multiplication between a constant and variable term. You multiply the constant and coefficient and keep the same exact variable part. Okay, now we'll look at simplifying more complicated variable expressions involving multiplication in the examples video for this topic. But before we get there, before I close out this lesson, I want to show you that the properties of multiplication that we went over at the beginning of this video still apply to the multiplication that we are performing here between a constant term and a variable term, or really it applies to the multiplication of any two terms in a variable expression. Because as you progress through algebra and math courses later on, variable expressions will get more complicated, and so using these properties of multiplication becomes quite helpful. All right, so to start, I want to show you that the commutative and associative properties hold true. Specifically, when a is equal to 2, b is equal to 3x, that's our variable term in this case, and c is equal to 4. Okay, we're only looking at one variable term here. As a reminder, we're not going to look at how to multiply two variable terms until later in algebra. All right, so we have two constants, one variable term. Let's check out and see if these properties still hold true. So for the commutative, we want to test to see if a times b is equal to b times a. So we'll have 2 times 3x and see if that's the same as 3x times 2. So writing that out, we have 2 multiplied by 3x, and we want to see if that is equal to 3x multiplied by 2. All right, now remember, when we multiply a constant by a variable term, you want to multiply the constant by the coefficient. So in this case, 2 times 3 is 6. So we'll have 6, but then keep that same variable part of x. So we get 6x, and that should be equal to 6x over here. Let's see. We have a constant of 2. The coefficient of the variable term is 3. 3 times 2 is also 6. And we keep that same variable part, so we get 6x on both sides of the equation. The property holds true even when we're working with variable terms. Now for the associative property, we want to involve an extra constant of 4. That's our value of c. So let's set this up. In parentheses, we will have 2 multiplied by b, which is 3x, and then that will be multiplied by 4. So we're multiplying by another constant. We want to see if that is equal to when you have 2 multiplied by b times c, or in this case, that would be 3x times 4. All right, so simplifying here, you want to start with what's in the parentheses. 2 times 3x, as we've already shown over here, is 6x. 2 times 3 is 6, but then you keep the same variable part. So we have 6x times 4 on this side of the equation, but then on this side, 3x times 4. To simplify that, multiply 4 by the coefficient. and 4 times 3 is 12. So you'll have 12x. You want to keep that same variable part. So on the other side of the equation, we have 2 times 12x. Now let's see if we get the same result on both sides of the equation. Simplifying these two variable expressions, remember that you want to multiply the constant by the coefficient of your variable term. In this case, 6 times 4 is 24, and you want to keep the same variable part, so we get 24x on that side of the equation. And then on the other side, 2 times 12 is 24, so we also get 24x. We're going to keep that same variable part. So we have 24x on both sides of the equation, and so the associative property for multiplication also holds true when working with variable expressions. Okay, let's look at our other three properties yet. The last three just involve working with one particular value. So in this case, we're going to let a equal 3x, a variable term. And so let's see if the zero, identity, and inverse properties still hold true when working with a variable expression. Starting with the zero property, we're going to have 3x multiplied by 0. And so following the same pattern of how we multiply a constant and a variable term, you want to multiply 0 by the coefficient of the variable term. So you'll have 0 times 3, which is 0, and then you want to keep the same variable part. So this would be equal to 0x, but anything times 0 is 0, which is what we're basically showing here. But because the coefficient of x is 0, we would just say that that is 0. All right, so you don't even need that x there. 3x times 0 is equal to 0. All right, anything times 0, even a variable term, is 0. So the zero property holds true. Now for the identity property, we want to multiply 3x by 1. So we have 3x times 1. And so if you multiply the constant by the coefficient, 1 times 3 is 3. And then you keep the same variable part, so you will get 3x. The identity property holds true. We use that rule for multiplying a constant by a variable term, multiplied the constant by the coefficient, kept the same variable part, and we have just shown that the identity property works even if you were working with a variable term. A variable term multiplied by 1 is still equal to that same variable term. Now finally, we have the inverse property. This is the last property we need to check. So if a is equal to 3x, we'll have 3x multiplied by its reciprocal, or in other words, 1 divided by 3x. And is that equal to 1? It should be, and it is. 3 divided by 3 is 1. So really you could cancel those out because you have a common factor in the numerator and denominator. 3x would be multiplied into the numerator. So that's why we can cancel those out. And the same thing would also be true for x, right? It doesn't matter what that variable of x is equal to. Both of those x's would be equal to the same value. So if you think back to evaluating variable expressions, if we said in this case that x was equal to 2, well, you'd have 2 divided by 2, that's equal to 1. Or if it was equal to some other number like 7 or 9, you'd have 7 divided by 7, that's 1. 9 divided by 9, that's also 1. So it doesn't matter what that x is equal to, x divided by itself is equal to 1. That x cancels out with itself. So all we're left with is 1, so the inverse property holds true. Anything divided by itself or multiplied by its reciprocal will be 1. Okay, and so that's it. We have just shown that the inverse, identity, zero, and then on the other page, the commutative and associative properties of multiplication all apply when simplifying variable expressions. Okay, and so that's all there is to this lesson on the properties of multiplication and simplifying variable expressions. But if you do want to get some more practice actually simplifying variable expressions using multiplication and its properties, feel free to check out the examples video for this topic that I'll have linked here on the screen. If you have any questions, please let me know in the comments. But if you don't have any questions, this is all I had for now. So I will see you next time.